Solve for t in this equation. I'll read off the equation. T is equal to a fraction where the top is 3 times the quantity 4 minus tr, and then that is all over a 2. The thing that we notice about this equation is there's a t on the left and there's a t on the right. So this is a little awkward because t is written in this equation here. T is written twice, and there's one T on each side. So we'll have to take care of that somehow. And in spite of not knowing the value of the variable r, we'll just do things to both sides. Now, some people will make the option of taking this 3 and distributing it to the 4 term, as well as to the tr term, and then basically turning the numerator into 12 minus 3tr right away. And that is an option. I will actually take care of this 2 in the denominator first. So there's kind of two different ways where the work will look basically the same, but your first and second steps might be swapped from the order I would do things in. I'm just trying to get rid of fractions, I guess, as quick as possible. So I'm going to say, in order to not have a 2 in the denominator, or rather to just not have any fractions at all in the problem, I'd like to multiply both sides by 2. And what that's going to do right away is take a look at the new right side. It's just the numerator from before, so 3 times, and then in parentheses 4 minus tr, close parentheses. The 2 that was in the denominator is gone because we times both sides by 2. But what that does to the left side, which used to say t, now we have 2 times t. We just wrote 2t without a multiplication sign. Okay, good. So compared to the original equation, we still have the problem of a t on each side, don't get me wrong. There's a t on the left and a t on the right, but at least we don't have fractions anymore. So there's a t on the left side, there's a t on the right side, and you've got options. Some people would choose to divide both sides by 3, and that is one thing that's going to work, though. That will create some fractions. So I think my hunch is to first distribute this 3 because you have kind of this one term with 2t here, and over here you don't even have terms. You have factors, right? You've got these pieces of multiplication, both the 3 and the 4 minus tr is the second factor, that entire thing in parentheses. But if we distribute that 3, so we'll have 2t's, the left side stays the same. 2t is equal to 12 minus 3tr. Now we have terms. So there's a 2t term, there's a 12 term, and after this minus sign, there's a 3tr term. And the deal now is when we have terms, we would add and subtract on both sides, and it will help us if we get all the terms that involve t on one side. It could be the right side, it could be the left side, but I'll make the choice to get all the t terms on the left side. So let's leave this 2t here on the left side, but if we add 3, we have to undo subtraction here. So if we add 3tr to both sides, we have a plus 3tr on the left because we added, and then on the right side, the plus 3tr would undo this minus 3tr, so we just didn't write either. We just have the 12 that's left over here. Good. So we went from this equation where there's a t on each side into this equation where both terms that have t are written on the left side, and all terms that don't have t, there only happens to be one term in this problem, but the only term that doesn't have t, which is a 12, and that's it, is written on this side. In a bigger problem, there might be multiple terms without t. So all terms with t are here on this side, all terms without t here, but we still have this issue of t is written twice. So in order to solve, we need to have one copy of that variable, and here's where factoring the variable is going to help. So outside of newly drawn parentheses here and here, I wrote this t, which is common to both terms. The term before the plus has a t, and then I'll highlight here the term after the plus, 3tr, also has a t, and that t could be written in front of the parentheses or after the parentheses, but then inside parentheses to finish our factoring we need this 2, and then t times 3r will be 3tr. Good. What this does, it helps us go from an equation where t was written not only once but twice to an equation where t is only written once. And we have t times all this stuff protected in parentheses, 2 plus 3r is equal to 12. And since we have t times this stuff, we have to undo times. Subtracting on both sides is not going to help. Well, we're going to divide both sides by 2 plus 3r. We're dividing to undo the times, and we'll be left with t is equal to 12 over 2 plus 3r.